Okay, let's simulate some quantum mechanics. Well, that's good enough. Okay, what? Maybe I need to do something else. Maybe a computer based on quantum physics would work. A quantum computer. But why would you need a quantum computer? If you are a scientist, you can run simulations to discover new medicines. If you like numbers, you can find prime factors quickly. If you are a secret agent, you can use quantum effects for absolute secure communication.
Can't a computer do this already?
To see their advantage, we'll ask quantum and classical to factorize big numbers and see how it goes.
First question, 8633.
89 times 97. 2017 times 1933.
Okay, so looks like classical can't keep up. Let's analyze.
Classical's best process takes dramatically more steps than quantum's when we increase the size of the number.
It doesn't mean that classical can't solve the problem, it just means that it will take a really long time. So I guess we have a winner.
Thank you, thank you, thank you.
Whoa, how did you do that?
A quantum computer operates on qubits. Qubits are a two-state system. They can be a trapped ion, a superconducting circuit, or a photon. Take a mouse and cheese in a box. There are two cases. The mouse eats the cheese or it doesn't. Now take a case with equal chances of him eating the cheese and leaving it. Now close the box and the cheese is in combination of both states in a state called a superposition. When we observe that superposition state by opening the box, there's an equal chance we'll find it in either state. Combination of probabilities of basic states gives us our qubit states.
But quantum computing isn't all cheese, so we have even more states.
Qubits can also be entangled when state of one qubit directly affects the state of the other. We can modify states of qubits with quantum gates which are arranged to perform computation.
We can use the vast amount of qubit states and the properties of quantum systems like superposition and entanglement to create processes that take less time even with large inputs. The speed up we gain is dependent on how we use these unique quantum properties to our advantage.
Whoa, all of this sounds so awesome. Now, can I get one?
Quantum computers right now are a fragile reality, operating in cold refrigerators affected by even the slightest of disturbances. But that doesn't stop us from trying. They may not replace our current computers, but they will sure help us discover some wonderful things.